All right, so for today's notes, we are moving on to our next part of which is comparing the function notation and the arithmetic sequence. We talked about the arithmetic sequence on KC1, which is a formula that I told you should write on the pink paper that I gave you, or the white one, depending on which class you were in. The arithmetic sequence. I'm just going to give you a review of what this sequence looked like. I'm pretty sure you guys remember an equals a1 plus parentheses n minus 1 times d. I explained to you that n is a term number, and in case you forgot, make sure you're writing this down. All right, and then I had a1. a1 is a first term in the sequence. And then I explained to you that D is the difference. D is how much is it changing by. So it's the difference, which is also the change. So it represents the change. Well, the arithmetic sequence is the same thing as the function notation, okay? So I'm going to explain to you one thing that they have different, but everything else is the same, okay? The function notation is the equation of a line, which is called the slope-intercept form. All right, why is it called the slope-intercept form? Well, because the equation is, again, f of x equals mx plus b, which again, f of x, we know it's y, so another way that we can write this is y equals mx plus b. Both of them are the same, okay? You just need to understand that f of x is the same thing as y. Okay, and what does this f of x and y represent? This means your output, your answer, right? Your final answer, your output. All right, the x represents your input. What are you putting in? So input. And the most thing that we have to remember is m. M is the slope, and that's why it's called slope intercept. Slope is m, is a change. Okay, so I'm going to write it right here. M equals change. And again, it's the same thing as the arithmetic sequence because D is a change. So notice how I'm writing those two in the same color. All right, and then it's called the slope-intercept form because we have the B. The B represents your y-intercept. And I talked about this earlier, is where your line is crossing through the y. That's why it's called the y-intercept, right? So that's why the name for this equation is called slope-intercept because we need a slope and we need the y-intercept. The B, however, is a starting point. The starting point will always be when x equals 0. In case you didn't notice yesterday or the days before when we were graphing, when we're doing the slope, I told you that the first point is where the line crosses through the x, right? So let me go back to the notes from earlier. I told you that this point right here is your starting point. If you get the coordinate point of this will be 0 and 3. X is 0, right? And your y represents the starting point. Well, x will always be 0. That's all you need to understand, that for the y-intercept, x, it will always be 0. And that's something that you need to remember, okay? Yes is the starting point when x is 0, okay? So notice the difference between function notation. The starting point is when x is 0. And for the arithmetic sequence, a1 is a first term they give you, okay? Now when a1, okay? Technically, what I'm trying here to explain to you that a1 is the first number for the arithmetic sequence, but for the slope-intercept, your y-intercept will be when a0. a0 represents your y-intercept, okay? Really easy how to do this, okay? You just have to understand what the problem is giving you, okay? So let's try the first problem together. This is the problem right here. It says a tree is currently 10 feet tall and grows 2 feet per year. Two numbers to pay attention to, 10 feet and 2 feet. What is a 10 feet represent? Well, it's currently. That means that's how much it starts with. And it grows. That means growing means that it's changing. This is your change right here. It's changing 2 feet per year. Okay. Now that I understand that, let me write the first answer to the first question. It says model this scenario with an arithmetic sequence. Okay, that means I need to write the equation. And again, my equation is an equals a1 plus n minus 1 times d. Once again, all you are going to be switching here is going to be the number for D, that's all you need, and your A1, that's all you need. You need a number for A1, a number for D, everything else stays the same. Okay, remember, we don't know the term number, so then we're just going to leave it like that. Everything else is AN equals plus n minus 1. Oops, I forgot that 1 times D, right? Okay, I need a number for D and an A1. Well, it says currently 10 feet. That is the starting one. So this is 10. And I just said that the growth is the change. So change is 2. So then there you go. I wrote my equation, my arithmetic sequence equation. Next question. Rewrite the explicit form of the sequence using function notation. All right, now we have to write the function notation that f of x equals mx plus b. Once again, f of x stays the same. X is your input, stays there. It's a plus. What I need to know is my m and my b. Okay, that's the numbers I'm going to plug in. Well, I already know M. M is a change, right? And I even put them in the same color here. M equals change, D equals a change. D for this one is 2, so guess what? M is 2. The change is 2. B is the starting point when X is 0. And I told you earlier is when A is 0. That will give me my number for B. Notice how for the arithmetic sequence I have A1 equals 10. Remember, the change is you're telling me that A2, all I have to do is add 2 because it's changing by 2. So 10 plus 2 gives me 12. A3 is going to be 14. Again, I'm just adding 2. However, to do the function notation, remember I need to find A0. A0, okay? I need to go backwards. If I'm going backwards, then I need to subtract from 10 minus 2 gives me 8. That means that my starting point for this one, for the function notation, will be 8. Okay, again, I'm looking when x is 0. Okay, another thing that I want you to know is that x is your input. Is your input and n is the input. Is a term number. Okay, this right here is a term number. This is the term number, this is a term number, this is the term. Okay, term number n is the same thing as the x for this one. Okay, so all you need to really find out for the function notation is your A0. You can do that once you know your A1 for the arithmetic sequence. Okay, and once again, 8 plus 2 gives me 10. Okay, so it follows the sequence. So for the function notation, I have 2x plus 8. Now, the third question, it says, how tall will the tree be in 5 years? 5 is your term number. And I told you right here that your term number is n for the arithmetic sequence or x for the function notation. It means the same thing. So for the last question, now that you have both equations, you can figure out the answer by either doing the arithmetic sequence or the function notation. I'm gonna do both of them so you know that you get the right answer for both of them. So you have A, 5, because that's the term number, equals 10, okay, plus n, which we know it's 5, so let me change that, 5, okay, minus 1 times d, which in this one is 2, Okay, once again, I told you all you have to do for these, okay, put them in the calculator, and we all know how to do that because we did it in KC1. And if you're struggling, make sure you ask me how to work the calculator. So all you're gonna do is literally plug in everything you have. 10, and remember, you're only plugging to the right side. So 10 plus 5 minus 1 in parentheses times 2, that's gonna give me sorry, let me change my color here. A5, which is in 5 years, I'm going to have 18 inches. Is it inches? Yeah, feet. Sorry. The tree is going to be 18 feet. Okay. Now, let me do the function notation. I have f of x equals 2. 2x, x, I told you that is a term number, and this one is 5. We put that in parentheses because we're multiplying, okay? 2 times x, that's what's happening here. 2 times x. So it's 2 times 5. And then we have the plus 8, okay? Once again, all I'm going to do is put this on the calculator. 2 times 5 plus 8 is going to give me 18. F of x, sorry, I should have put 5 here because x is 5. Sorry. There you go. So f of x, a function of 5 years, will be 18 feet. Once you have both equations, to get the answer to the last one, all you have to do is plug in the value for x or n. Okay? I'm going to do one more, and I'm going to go a little bit more faster with that one. Okay? It says a tree is currently 4 feet tall and grows 6 feet per year. Okay, currently means that you're starting with that. Grows means that you're changing. This is a change. All right, first question is that I need to write it in arithmetic sequence. That an equals a1 plus n minus 1 times d. Again, an stays the same. I don't know the term number for this one yet. That's why I haven't changed the n. I don't know the term number. For this one, I only know the beginning. It starts at 4 plus n minus 1 stays the same times the change. The change is 6. There you go. Again, a1 equals 4. The change is 6. That means I'm adding 6. So a2 will be 10. I'm adding 6. A3 equals 16, right? I'm just showing you the pattern here. All right. For this second question, you need to write as a function notation. F of x equals mx plus b. Again, f of x is the output, stays the same. M is a change. The change is 6. 6x plus b. B is the starting point when A0, for A0. That means I need to subtract because I need to go backwards. So to go backwards, if I'm adding 6 to go forward, to go backwards, we do the opposite. 4 minus 6 is going to give me -2. So for this one, I'm going to have -2. And I told you every time we have negative numbers, we put it in parentheses. So that's my function notation. Then for the last one, you can use whatever equation you want. Again, plug into the value of n or x. It doesn't matter. I'm going to do it for f of x. F of 10 equals 6 times 10 plus -2. Again, you plug this in the calculator. Literally everything you have here, make sure you put that -2 in parentheses. You have 58. Your answer for after 10 years is going to be 58.